Okay, so we're going to be looking at the basics of kinematics. Usually we're building up to the end of the unit, which is kinematics motion in 1 dimension, and then we're looking at kinematics motion in 2 dimensions. So I wrote all the kinematic equations that I would like to write. I like them in this form. Some books write them in different forms, but this is the way I like to memorize them. But the basic idea here is there are 5 variables that we want to keep track of. We want to keep track of the displacement, the velocity, the initial velocity, the acceleration, and time, right? We want to keep track. So let me just write this. This is displacement. This is final velocity, initial velocity, acceleration, and time. And usually these are the units: meters, meters per second, meters per second, meters per second squared, and seconds, usually. So what we want to do is keep track of these and make a table. Actually, we want to make a table. So this is how I like to set up the table. I just put a line here, I just put X, I put V, V naught, A, T. And as you get better at this table just becomes something you probably skip sometimes, and probably you go quickly on. The main idea here is there are 5 quantities. If we know 3 of them, then we can find the rest. For example, let's say I know this, I know this, and I know this. I can find the rest of the variables easily using one of these equations. The hard part is actually determining which one you know, which one you need to use. So what I see is that I don't know acceleration, so anything with A I'm not going to use. I know A I'm not going to use, so which one doesn't have A is this one, right? Oh, this one. And what can I do? I know, let's see, I know this term, I know this term, and I know this term. Oh, I can solve for this term, right? So then, therefore, I can solve for V and get that equation. And then let's see if I can find A, right? We have 4, so we can for sure use one of them to find A. Let's use this one. This one's probably the easiest one to use to solve for A. So then I can find all 5, right? Let's do another thinking thing about it. So let's say I know this one, and this one, right? I don't know anything about the velocities, but I do know about position, acceleration, and time. Well, let's see, which one can I use, right? I'm trying to see which one doesn't have both the velocities, and it's this one. I can solve for velocity here because I know time and acceleration and position to find velocity. So if I find velocity, I can find the final velocity, right, using this equation right here. Let's just do one more for good luck. Let's say I know not the position. Let's say I know this, and let's say this, right? I don't know anything about time, how long it takes, nor how do I know how far I go. So we want to look at an equation without one of these things. So the one I see that jumps out straight to me is this one. This v squared equals v naught squared plus 2a delta x. From this I can find delta x, right? I can find delta x, and then I can find time using, which one's the easiest? This one's usually the easiest to find time, right? So if you know 3, you can find the rest. That's kind of the idea. If you know 3, you can find the rest. So we're going to do one example of this. So here's a common example of using one-dimensional kinematic equation. A ball rolls down across a path with an initial velocity of 10 meters per second. The friction slows the ball at a constant acceleration of negative 1.4 meters per second squared until it stops at rest. How long does this take, and how far has the ball traveled? So what we want to do is do the table, right? So what do we know? Do we know anything from this? Right? How long does this take? We don't know this, right? So it's a question mark. We don't know how far it traveled. We do know its initial velocity is 10 meters per second, and we know it's slowing down at a rate of 1.4. And then something that a lot of people have a hard time finding is whenever they say rest, right? Rest is always 0 meters per second. So we found 3, right? We found 3, so that means we we can solve for the rest. So let's do t, because t's probably important here. You can do either or and use an equation that uses it, but I'm going to do it t. Let's see. I'm going to scroll up and look at the kinematic equations, right? Which one do we have? Let's see. Which one do we have? The velocities and the acceleration? It's the first one. So v equals v naught plus at. If you memorize these equations, you'll probably have an easier time figuring out which one you want to use. So now we just plug in what we know, right? 0 is equal to 10 plus negative 1.4 t, and then we want to solve for t, right? So we just bring the 10 over, minus 10 equals negative 1.4 t, so then t is equal to negative 10 divided by negative 1.4, and then using a calculator, I'm going to use a calculator, we get, I'm going to round to the nearest hundredth, 7.14 seconds, right? It takes 7.14 seconds for the ball to stop, right? Given this initial velocity and this acceleration. Now we want to find the position. So thinking about the equation, we can use two equations because we know 4. But I'm going to use this one. This one's probably the best one to think about. The other one I was thinking of is this one. Oops, plus 2ax. But this one I just don't want to, because you have to solve for a lot to get to here. Well, this one is already done for me. This is why I kind of like this format than a different format some textbooks like to take. So let's go ahead and solve this. We just plug in what we know. 10, and then we know 7.14 plus 1/2. Remember, the sign has to be the same. It has to be that specific sign because it is negative in the negative direction. So 10 times 7.14 plus half times negative 1.4 times 7.14 squared. What do I get? I get a distance of 35.7 meters. So in all, we can actually complete this, right? It takes 7.14 seconds and it travels 35.71 meters. And this is basically the idea of solving it kinematic style, one dimension, right? We want to make this table. We want to at least hopefully find 3 quantities, and then we use equations to solve for the other. I think you need to be really, or I think you should actually memorize these equations instead of trying to refer to them on like an equation sheet you're given, because it's just so much more helpful. It makes you do it much more faster, and you'll be pretty fast at these types of problems, because these problems take a while if you don't know the equation you're using, because you have to look back and forth. But if you know them, I like this one. This one is probably the one used a lot, and this one's a close second. So that's it for this video for one-dimensional kinematics, and we're going to look at some more problems in the next video.